Hello everyone, welcome back. In this video, we're going to introduce some new iterable objects. Iterable objects are informally things that look like lists. They are container type objects that can be for looped over. So first up is tuples, and tuples are very similar to a list, except they are immutable. The syntax for a tuple is you just type t is equal to open bracket 1, 2, 3. If you want to get the first element of the tuple, you just type out t0, which is 0. And you can also for loop over a tuple. So you can say for t in t, print t. Now, like I said, the main difference between a list and a tuple is that tuples are immutable. And so with lists, this is perfectly allowed. You could say L is equal to 0, 1, 2, 3. And then try to change L of 0 to be equal to cat. And now we could print out L for L in L, print F. And now it prints cat 1, 2, 3. However, if we tried this with a tuple, let's try using the exact same code, but with tuples. So we're going to copy and paste it. Okay, and since it's a tuple, we should call it T, and we should use curly braces. But this really is essentially the exact same example, but with the letters changed. And let's use T for T and T, print T. This is not going to work. Tuple object does not support item assignment. And okay, maybe you're thinking, well, okay, maybe it's because I tried to change it from an int to a string. Well, okay, let's try changing t0 to 10. Nope, still same thing. Tuples are immutable. They are very similar to lists, but they do not support item assignment. They're kind of like strings. You can't just say t of 0 is equal to some stuff. And this is because tuples have a rigid structure. And one thing is that the rigid structure does give you some examples. So let's say we have two tuples called letters, where letters is equal to A, B, C, and numbers is equal to 1, 2, 3. We can combine these two tuples to get what's effectively a list of tuples by using the zip command. So we write pairs is equal to zip of numbers and letters. And now let's take a look at pairs. Okay, well, printing pairs doesn't actually, it just says it's a zip, so that's not particularly cool. Let's take the list of the pairs. And when we get a list is we get a list of 1A, 2B, and 3C. So the zip command can turn two tuples into one list of tuples. And you can also zip multiple items at the same time. So let's go with, instead of just zipping letters and numbers, let's also zip our Roman numerals, where our Roman numerals are going to be the tuple of 1, 2, 3. Roman numerals. And let's print a list of pairs. Pairs is now kind of a little bit of a misnomer, but we can see that we get 1A and I, 2B and II, 3C and II. So that's it for our intro to tuples. Now let's move on to sets. So for sets we use curly braces. Sets are going to be kind of like a mathematical set, if you're familiar with such things. If not, don't worry, this will all become clear. So we can say my set is equal to 2, 3, 4 for S in my set, colon, indent, print S, 2, 3, 4. That looks good. And we can add items to the set. So let's print my set, and then do my set dot add. Let's add 5, and then let's print my set again. Alrighty. Now the distinctive thing about a set is that you can either be in the set or you can't, but you can't be in it twice. There's no repeats. So let's try adding my set to 5 again. All right. It did not add it again. It just still is just 5 is only in there once because you can't be in a set twice. Now, in addition to taking things into a set, you can also take things out of a set. So let's remove the number 2. My set dot remove 2, and now let's print my set. So sets also support a number of operations: union, intersection, and set difference. So let's have the first set be called S. S is equal to 1, 2, 3. And T is another set, which is going to be 3, 4, 5. S dot union T. This is going to give us all of the elements which are in S or T. So this is going to give us 1, 2, 3, 4, 5. 3 will not be repeated twice because you're either in a set or not. You can't be in it twice. Intersection gives us things that are in both S and T. S dot intersection T. So that's just 3. 3 is the only one that's involved. And difference, S dot difference. Difference has 2 F's. Well, this is going to give us the difference without that S at the end, the elements of S which are not in T. So this will just give us the 1 and the 2. Now, a nice application of sets is that you can count the distinct items in a list. So we could have some long list with some repeats: 1, 2, 3, 2, 3, 3, 2, 4, 8, 4, 3, 2. And the length of L is equal to 13. But how many distinct items are there? So we could have S be the set of L. And now we can look at the set of L, and we can see that the distinct items in the list are 1, 2, 3, 4, 8, and 9. And we can look at the length of S, and this will give us the number of distinct items, which is 6. So while there were 13 items in the list, there are only 6 distinct items. And so as is kind of a running theme, we are going to end on a cautionary note, which is the following thing does not make any sense. There is no such thing as the first element of the set. The things about sets are you're either in the set or you're not, and there's no order and there's no repeats. So that's it for sets. I will see you guys again next time.